Okay, so this is going to be the second to last video, chemistry related, that I'm going to do for a while. This one is actually just going to be a simple demonstration, or at least a couple of them. I have two knives here. One of them, the one on my left, was actually brought to me by my grandparents several decades ago. And my parents claimed that it was, sterling silver. It's not, but the silverware that these knives came from was actually a hotel. So apparently my grandparents were thieves. I have a knife on the right-hand side that I know for a fact is stainless steel. Before I do any sort of chemical testing on either of these, however, we're doing a quick test right now. Some physical tests. I cannot measure the density of the silverware for a couple reasons. Firstly, I don't have a way to accurately measure it. My scale is kind of dead, so I can't really measure mass. And my grad cylinders don't really hold enough water to actually measure something as large as this particular knife. So first, we're testing heat capacity. Silver has a higher heat capacity than stainless steel, meaning the ice cubes that I've placed on both of these knives, the one on the silver should melt first. And so far, that's clearly been the case here. It's hard to pick up. They were both slightly different size, so this isn't the most accurate test, obviously. We're going to do a couple more. But because the one on the left is melting a lot faster, this indicates to me that there is in fact silver on this knife. Now, it's not pure silver, it's obviously going to have some other metals mixed in with it. If this was a pure silver knife, this would be worth a lot more than a hotel would be willing to let somebody just steal it or use in the kitchen. One easy physical test we can use to at least determine that the metal on the left-hand knife is different than the metal on the right-hand one is a very simple sound test. So let's go ahead and take the inconclusive ice cubes off of these knives and just let that soak up. Test 1. This is the stainless steel knife. It's kind of a dull sound when I tap my fingernail against it. This is the theoretical silver knife. By comparison, it'll work better with a metal object. Here's my stainless steel kick clip. Stainless steel on stainless steel. Stainless steel on silver. So we can clearly see that these two knives have different properties. This one has a thicker base, so perhaps that is to blame for the acoustic differences because the base over here is thinner. However, I don't really think that's the case. In terms of physical testing, that's kind of a limit where I'm at right now. There are other things I could do, but really there's only one test to have. I'm relatively okay with damaging a small portion of this particular knife, maybe at the base over here, just to demonstrate that we can in fact chemically react the silver in this metal. And I'm okay with doing the same with this one, because this I can just get a copy of at the dollar store. So what we're going to do is we're going to react a small portion of both of these knives with an acid. We're going to use hydrochloric acid in this case, since silver chloride should form readily. The stainless steel, I'm not entirely sure what it should react and form, but I'm going to go ahead and look that up right now to see what the differences will be, and whatever the visible color difference is will indicate what the compounds are, what the metals are composed of. Silver chloride should be a whitish powder, so this should have some sort of white discoloration, maybe on the base tip right here. I'm not sure what steel will react with hydrochloric acid in form. I have to look that up. So I'm going to go ahead and do that right now. Okay. I really should be wearing gloves and goggles for this, but since this is a very quick demonstration, uh, yeah, I'm just not going to bother. If anybody is watching this, you absolutely should follow safety procedures in everything you do. We're just going to pour a little bit of the acid to a beaker and then sort of pipette it onto the knives. Yeah, we're not going to use that much. There we go. Okay. So let's go ahead and start with the stainless steel knife. One with a thinner base. A couple drops. So after pipetting on the acid, it is reacting and forming a black solid. Hard to pick up on camera, but I assure you it is black. So that's probably the steel reacting. There's some chemical discoloration right there. And now we're going to do the same thing on the silver knife. The discoloration should be white. I don't know what it's going to be with the different metals in this knife, but it should not be black. Okay, so I've just poured a couple drops of the acid onto it, and it is reacting very slowly. Actually, I don't think it's reacting at all. Well, theoretically, that may make sense in one case. If this is a silver alloy, meaning it's mixed in with another metal or several types of metals, it technically should be less reactive than the pure steel knife, which is actually an alloy too, but it is still somewhat reactive. No visible outward signs have occurred. Changes. Let me go ahead and try that on the thinner part of the knife as opposed to the base. We don't need that much, just a few drops. There. No reaction. That's interesting. There is no visible reaction. Oh no, there is. Okay. It is very, very hard to see, but there is some gas bubbles being produced and trying to make their way to the surface. Let me see if my camera can get that. No. Yeah, my camera cannot pick that up. There we go. Okay, I'm gonna wipe it off now. Alright. That whitish gray circle there is where the acid drops were reacting with that part of the knife. That is indicative of silver chloride and probably some other salt, depending on what metals are in this. So it's not pure silver. That's not coming off anytime, but that's okay. It's not pure silver, but this absolutely does have silver content in it. I just don't know how much or what concentration. Okay, and the next chem video that I'm going to be doing is going to be much more comprehensive. It is going to be specifically on copper metal. Have I been recording? Yes. Okay, good. I scared the hell out of myself thinking I wasn't recording. Oh no, I'm not recording, am I? Yes, I am. Okay, so the next video I'm going to be doing is going to be a comprehensive elemental series on copper. And we're going to do a lot more demonstrations and tests. I'm going to talk more in depth, specifically about ligands and metallic chemistry in general. So, stay tuned. Thanks for watching.